So new FRQ now. So the FRQ gives me a graph. Key things to, like, go slow and careful, don't go fast. Key thing to notice is the graph is a rate. So the graph's a rate. So if I'm thinking Danica's chart, they're giving me the middle column on Danica's chart. The rate of fuel consumption in gallons per minute. I often earn points for units, so I'm going to keep track of that. Recorded during an airplane flight. It's given by a twice differentiable and strictly increasing function. Twice differentiable is a clue that is given in many AP problems and is rarely needed. So don't forget it, but don't worry about it yet. Strictly increasing is a clue that is much more likely to be used. So here's my graph of R. So capital R is the rate of fuel consumption. This is the table for R. Okay, good. So now the question. Use data from the table to find an approximation, keyword approximation, for R prime of 45. So they want the derivative of R at time equal 45, but they only want an approximation. So I remember this box from the golden notes right here, to approximate an instantaneous rate of change. Because they are asking me to approximate R prime of 45. So this box on the golden notes applies to what they are talking about. I'm trying to approximate R prime of 45. I am approximating an instantaneous rate of change of R. We do that by calculating the average rate of change, or in other words, we're going to approximate a tangent slope with a secant slope. Said that kind of fast. One more time. Average rate of change means the same thing as secant slope. Instantaneous rate of change means the same thing as tangent slope. This symbol represents tangent slope. This is how I calculate secant slope. So this represents the instantaneous rate of change of F at time equal 4. This is how you calculate the average rate of change of F between time 7 and time 3. So I'm being asked to approximate the instantaneous rate at which R is changing at time 45. I do that by finding the average rate at which R is changing. So I note, at time equal 50, which is the time, like I'm supposed to find time 45, but there is no time 45. So instead I pick the time after 50. And notice that at that time, R is equal to 55. So write that down. At time 40, R was equal to 40 gallons per minute. So during this 10-minute time period, the rate of fuel consumption went up from 40 gallons per minute to 55 gallons per minute. That's an increase of 15 gallons per minute. That occurred over a 10-minute time period. If I write this on my paper, I will get full credit because I have specified a difference quotient. This is a quotient, something divided by something else. This is the difference, I have to show that. And then I also have the correct units. So my preference is to stop right here, because I have shown the difference quotient, I've got the numbers. You don't have to go further. This was just trying to explain what they're talking about. That the fuel consumption at time 40 was 40 gallons per minute. And then 10 minutes later, the fuel consumption is 55 gallons per minute. So they're asking me to approximate how fast that fuel consumption is changing. And so I can multiply it out, but I wouldn't recommend it. It's safer just to stop here. 1 point for the red, 1 point for this box, 1 point for the correct units. Either of these units would be sufficient. 2 points total for this problem.